Hi, my name is Yandong, and I will present our paper on self-supervised 3D face reconstruction via conditional estimation. This is a joint work with Weiyang, Bhiksha, and Rita, Singh. Reconstructing 3D faces from single-view 2D images has been a long-standing problem in computer vision. The general approach is based on an autoencoder, where the 3D facial parameters are estimated from the 2D face image, and then recombined to reconstruct the 2D face image. The model parameters are learned to minimize the reconstruction error. As can be noticed, the target 3D facial parameters are all individually estimated, and we argue that it may not be always correct, because it implicitly assumes the conditional independence. In fact, the captured 2D images are reduced dimensional projections, representing a joint interaction among the four facial parameters. As a result, the constraints they impose on one another are ignored if we use the conditionally independent modeling. Inspired by this, we propose a novel learning-based framework based on conditional estimation, which is also called CEST. CEST explicitly considers the statistical dependency of the 3D facial parameters, so that the estimation of any 3D facial parameters is not only conditioned on the given image, but also on the facial parameters that have already been derived. Here are the comparisons for two types of 3D face reconstruction methods. CEST combines the advantages from both. We present a specific and intuitive solution in CEST, where the viewpoint, facial shape, facial reflectance, and illumination are predicted sequentially and conditionally. In this context, the prediction of the facial shape is not only conditioned on the input images, but also on the derived viewpoint. Similarly, the prediction of facial reflectance is conditioned on the input image as well as the derived viewpoint and facial shape. The renderer takes in the four facial parameters and produces the render image. This framework is learned by minimizing the reconstruction error. To avoid getting degree solution, we adopt two regularizations: reflectance symmetric and consistency in a video clip. Instead of adding additional regularization terms to the objective function, we construct additional reconstruction terms for the horizontally flipped reflectance and reflectance from other video frames. We train the model to minimize these reconstruction errors simultaneously, so that the illumination can be effectively separated from the reflectance. We conduct experiments for CEST on voxel1 dataset, where we use a subset of 267 people with more than 4,700 video clips. They are the results from our ablation start and the comparisons to other state-of-the-art methods.